pretty short overview. I try to make it short and not step into details here. So support structures, or this is a description of the process. Once again, it's not important, but in general, support structures are not only needed in additive manufacturing. So a clamping device is also a sort of support structure for milling, or the cast. For casting, you also need the mold cast, let's call it this way, which is also a sort of a support device. But the difference is you can use them normally, the clampings in the milling and the cast, the mold, I think it's called cast, for molding multiple times. The supports in additive are, you have to print them each and every time. And this is the reason why this means that the costs are spared over the number of pieces. So yeah, you have the same part costs from the first part beginning to the last part, which is beneficial in some cases in comparison to the conventional manufacturing processes. And there's a break even till which point additive manufacturing is beneficial, and when conventional manufacturing is, or subtractive manufacturing is, more beneficial. And this break even was long time at about 100 pieces, or let's call it nowadays less than 1,000 pieces. Till 1,000 pieces of a part, it's pretty interesting to use additive manufacturing. After that, when you need millions of parts, then standard or conventional manufacturing procedures are getting more in the focus. One thing why we need support structures is the connection to the build plate. So when I print this cube, for example, and I put it directly on the base plate, I will have the problem that I lose geometry when I remove the part from the base plate, because you have to cut it off. So this, for example, 10 times 10 times 10 cube will, after cutting off, only be 10 times 10 times whatever, 8 millimeters. So this is the reason why you need any subtraction or any additional material to the base plate. It's one reason why I need this one. Islands are also a typical point. So in this area, it's also connecting to the base plate. You cannot start geometry in loosened powder, because the recoater will simply remove the geometry in the powder bed till a certain point, and then so that the output will not be a good one. So if an island, like here, for example, is visualized, is generated over the build up, you have to support it in a certain way so that it will not be removed by the base plate, by the recoater. Here's a short example which I have printed on our machines. It's a lattice structure, it's a lightweight structure, and the connection from these small pins was not good enough, and the recoater simply removed geometry in a way so that it's not accurate enough. Another thing, but there must be other things why we need that bunch of support structures underneath, and the reason for that can be found in thermal conductivity. When you think about a laser beam or a laser spot which is moved over loosened powder, and in one hand or on one side there is a solid material underneath, and on the other side there is loosened powder underneath, then you can find out that the thermal conductivity is completely different. So here you can see the temperature over a certain period of time, And when you scan over solid material, this temperature tail, let's call it this way, is pretty short. In comparison, when you scan over loosened powder, you can see the tail from the beforehand scanning. So the cool down is completely different over massive material or when you scan into loosened powder. And this effect can also be highlighted with a T cantilever, which is this, I hope it can be seen in this case. The heat transfer in this massive solid area is completely different to in this area where there is no solid material underneath. And different cooling areas indicates stresses, and stresses indicate deformation. And this is the reason why we need to support a part in a way so that we achieve a good thermal conduction. And when you think about the layer-wise building up of a part, you can find layer n-1 and layer n. And when there is an overhang of the part, which is more or less this angle here, you can find out that here you scan in loosened powder, and it's the same effect as it is shown here. You have a different cool down in this layer depending on if the scanner was moved over the solid material or the loosened powder. Different cool downs indicate stresses, and due to the stresses, you will end up in a deformation, and this will come a little bit up. Let's call it this way. And what you can see in this picture is there was no support here underneath, and it bended upwards so that the recoater crashed against this structure, and I have to stop the build job because it was simply the recoater was broken. And this is the reason why we need support structures to have the same thermal conduction in an area where you have a lot of overhang. And the other thing is why we need supports is the thermal expansion. So when you think about this area here, you will find out that the thermal expansion is different on the edge and on the corner. The reason for that is pretty simple. The distance from the middle point of the scanned area is different to the edge than to the corner. And due to the fact that when we are heating up material to the solidus temperature. So for example, for steel, the solidus temperature is about 1200 degrees. And then it cools down to 200 degrees, which is the environmental temperature. So I have a temperature gradient of 1000 degrees. And steel has a thermal conductivity coefficient of 12 microns per degree and per meter. So when I cool down a piece which is 1 meter in length for 1 degree, it shrinks 12 microns. And now I have a thermal temperature gradient of 1000. So I will end up in 12 millimeters of shrinkage for a 1 meter long device, let's go in this way. And this is a physical effect which always comes up. And so the shrinkage of a certain layer is something that the supports also has to deal with. And in this case, you can see that this edge was coming out as well, and the support was not stiff enough to hold the support, to hold the device in place. So that was the reason why it also breaks up here in this area.